Good morning, sir. This video is for the final project review of microprocessor and interfacing. Our topic is humidity and temperature monitoring system. Our teammates are Varun Buddha, TNS Kaushik, and I myself Ganta Rishik. Introduction. Arduino is a microcontroller that we are going to use for this project. In this project, we are going to get the moistness and temperature from DHT11 sensor and process it and send it to ESP8266 Wi-Fi module. This Wi-Fi module will send it to the ThingSpeak server. In this project, we have divided it into different sections. It consists of 4 sections. In the first section, we get the humidity and temperature from DHT11 sensor. In the second section, we process the data. In the third section, we send it to the ESP8266 Wi-Fi sensor. And in the fourth section, we demonstrate the outcome from ThingSpeak server. Objective. The objective of this project is that we are going to monitor humidity and temperature over internet using ThingSpeak, where we will show the current humidity and temperature data using ThingSpeak server. Literature survey. This literature survey will be explained by Varun.
So, the first paper we have taken from is Gopal Krishnamurthy. His observation for this project is the proposed system develops a smart wireless sensor network for an agriculture environment. Monitoring agriculture system detects environment factors such as temperature and humidity along with other factors can be of significance. The key point taken for our project is that the system is cheaper in cost and consumes less power and can control 254 devices or nodes. The second paper we have referred is Professor Mrs. S.S. Patel and her team. The observation we are taking for this project, the Zigbee smart sensing platform makes it easier to monitor environment conditions and plan the correct method for crop. The key point taken for our project is that microcontroller based measuring units which collect the values from different nodes like temperature, relative humidity, water level and soil moisture and stores and displays them into a database. The third paper we have referred is Miss Ragini D. Kadse and her team. And the observation we have taken for this project is from this project is implementation of wireless sensor network for real-time monitoring of agriculture parameter. And the key point taken for our project is that use of TCP/IP with microcontroller to get higher error rate, high speed, and also simplicity with support to expand farm field of a farmer.
And
Now
these are the
Kaushik will
components.
explain this.
Yeah,
The
these components we are used in our project. Arduino Uno, ESP8266, which is also known as Wi-Fi module, and DHT11 sensor and jumper wires and breadboard, and circuit and working. The DHT11 sensor senses all the humidity and temperature in the surroundings and sends the information to the digital pin 5 of Arduino MCU as shown in the given figure. From the Arduino MCU, the humidity and temperature values are updated to cloud at regular intervals of time through ESP8266, the Wi-Fi module. From the cloud, we can see all these values graphically on the ThingSpeak platform from anywhere in the world. Construction and testing. Arduino Uno reads the temperature and humidity data from DTH11 sensor and it sends to the server for live monitoring, and then it will store all the data, and from there we can see data, and this process usually takes about 15 seconds to update all the readings. And to use this, first we need to create an account in ThingSpeak platform. After that, we need to create a channel with temperature and humidity as fields. Once you created a channel, it will generate two API keys, read API and write API keys. After updating a program, the temperature and humidity data is updated on the ThingSpeak platform. And these are the code we used in the making of our project. And these are some of the screenshots of outputs. and here we can see that the temperature is around 34.8 and the humidity in the air is 60 percentage, and these are the graphs of temperature and humidity.
Now I
And
will show the output. Yeah, this is the device that we have connected. Here, ESP8266 VCC is connected to the 3.3 volt Arduino pin. Then the ESP8266 RST pin is connected to the 3-volt pin of Arduino. And then the CHPD of ESP8266 is connected to the 3.3 volt of Arduino. The RX pin of ESP8266 is connected to TX of Arduino, and the TX pin of 8266 is connected to the RX pin of Arduino, and the ground is connected to ground pin of Arduino. DHT11 VCC is connected to the 5-volt pin of Arduino. DHT11 data is connected to the 5-volt pin of Arduino. DHT11 ground is connected to the ground of Arduino pin. After these connections were made, now we connect the USB to the laptop and start the Arduino. DHT starts glowing. This means that it is reading temperature and humidity values from the atmosphere. Now these values are sent to the server. Now I will show the code and output from the ThingSpeak server. This is the code that we have implemented. Here we are using DHT11 sensor for sending the temperature and humidity data to ThingSpeak using Arduino and ESP8266 Wi-Fi module. The Arduino reads the values from the DHT11 sensor and processes it and sends it directly to the live server of ThingSpeak. Yeah, this is the code. Now I will upload the code into the Arduino. It is uploading. Yeah, now that it is done uploading, the sensor will calculate and it will start sending data. Data will be being sent to the server. Yeah, this is the ThingSpeak server. Here we can see that the values are being plotted in two graphs. One is humidity graph and one is the temperature graph. These are the values that we have presently. This is our project. Thank you. Now Varun will continue with the rest of the applications.
So, so this monitoring can be used in refrigerators which are used for storing medicines and vaccines. It is used in warehouses where temperature sensitive products are stored like chemicals, fruits and vegetables. They are used in walk-in freezers, cold storages and cold rooms. They have been used for monitoring the temperature of furnaces, processing machines and other industrial equipment.
Uh, these are the references. The conclusion that we can take from this project is that this project has many applications in the real world and it is very useful, and it has been very informative in learning during the course of this uh, during this course. Thank you.
thank you.